Hi there, in this video we'll be discussing various topics about statistics and probability. For my part, I will be discussing the concept of random variables. Random variables are technically defined as functions that associated a real number to each element of sample space. But let's make it simpler to understand. Random variables are numbers whose value is random. Let's say, for example, you are running a sari-sari store. The number of candies sold every day is considered as a random variable. Why? Because of the given itself. It says number, therefore satisfying the first condition stated earlier. Second, you cannot predetermine the number of sales for the candies, therefore it is random. There you go. A random variables. How about when we talk about kind of candy that is high demand? Will it still be considered a random variable? The answer is no. The reason is simply that the type of candy is not a numerical value. Now, let's talk about two types of random variable. The first type is the called discrete. When we say that random variable is discrete, it means it is countable. It has no values in between them. A great example of discrete random variable is the number of students present in classroom. First, it is satisfy the condition of random variable. It is a numerical value and the number of students present in a class depends on chance. Second, there is no such thing as half student. Therefore, there are no values in between, just as the description for discrete random variable states. Now, for the second type of random variable, it is called continuous random variable. It is described as the maximum type of random variable with an infinite number of possible values between any two values. An example of this is the volume of water in dam. It is a random variable for the volume of water in dam depending on certain situation. It is considered as continuous type because although we can measure the volume of water in a dam, we cannot exactly say its true value as it may be slightly more or less than what we assume.
For this part of the video, I will be discussing the probability distribution for discrete random variables. First, let us define probability distribution. Probability distribution shows us all the possible outcomes of an event and how likely it is to happen. Since it involves discrete random variables, we can list all of the possible values. Since probability is known as the ratio between the number of favorable outcomes and total number of possible outcomes, we can get the probability of each random variable by dividing the frequency and the total number of outcomes. The probability then can be expressed as a fraction or as a decimal. Take this as an example. You flip a coin 2 times. If you arrange it into a table to show how many times the head appears, your sample space will be S equals HH, HT, TH, and TT. And this probability distribution will look like this. Or simply, we divide the frequency by 4 because there are 4 possible outcomes in this example. And if we express the probabilities into decimals, it will look like this. Now that we have arranged them into a table, let's discuss the properties of the probability distribution for discrete random variables, just to check if we have satisfied them in our example. First, it states that each probability must be between 0 and 1 inclusive, and second, the sum of the probabilities must be equal to 1. Now, let's check our previous example. If you look at the probabilities, all of them are situated between the values 0 and 1. If we add all the probabilities up, which are 1/4 plus 1/4 plus 1/2, we get 1. Therefore, our previous examples table is considered as probability distribution.
Next up, we will talk about the mean, variance, and standard deviation of the probability distribution. First, let's provide a probability distribution. Here is an example of a probability distribution. Now that we have our probability distribution, Let's first discuss the formulas to solve the mean, variance, and standard deviation. For the mean or expected value, we follow the formula of mu is equal to the summation of x times px, or simply multiplying each of the values of random variables by its corresponding probability and then adding all of their products up. Both decimals and fractions are accepted as answers. However, when dealing with decimals, we are required to at least round it to 4 decimal places. Now, for the variance, we follow this formula. Sigma, open parenthesis, x minus mu, close parenthesis squared, times p times x. Or simply follow these steps. First, find the mean, and after that, subtract the mean to each value of the random variables and square it. You then have to multiply its result to the corresponding probability before finally adding all of the results to get the sigma squared or the variance. Lastly, to get the standard deviation, you just have to find the square root of your variance. The result of that process will lead you to the standard deviation. Now, let's apply it to our probability distribution a while ago. Observe the calculations to be seen on your screens. And there you have it, the mean, variance, and standard deviation of your probability distribution.
For our fourth lesson in this video, we will discuss the normal curve and its properties. A normal distribution or curve is a special type of density curve that is shaped like a belt. It describes the tendency for data to cluster around a central value. It is unimodal and only has one peak. The normal curve may be given a notation written as follows, which you may see on your screen. It is known to never touch the x-axis and continues to infinity. Now let's talk about the population mean. The population mean is known as the central value denoted by the symbol mu. It characterizes the position of the normal distribution along the graph, and it is where the data tends to cluster around. For the population standard deviation, it characterizes the spread of the normal distribution. It determines the height of the curve, whether the curve will be flatter or taller. To sum up all of the properties of the normal distribution, here is a summary table. You may pause the video or take a screenshot of it. And there you have it, the normal curve and its properties.
Converting from normal distribution to standard normal distribution and vice versa. Statisticians use the standard normal distribution as a basis to find the area under the various normal curves more easy. What they do is that they first calculate the possible areas under the standard normal curve bounded by z-scores. The variable on the horizontal axis is represented by letter z when we use standard normal distribution. We use the formula z equals x minus mu divided by the standard deviation in converting normal random variable x to its corresponding z-score, where x is the random variable that we are converting, mu is the mean of the normal distribution of x, and the standard deviation of the normal distribution of x. Here's an example of converting normal distribution into the standard normal distribution. The solution using the formula z equals x minus mu divided by the standard deviation. Here's an example of converting standard scores to normal distribution. The solution using the formula x equals the mu plus the z-score times the standard deviation. That's all. Thank you.
For the next topic, we will be tackling about areas under the normal curve or Z table. On this topic, we will be needing the Z table, so make sure that you have a copy of it for your reference. To determine the area under the normal curve, we will be needing the z-score, which is usually given in the problem. Since the equivalent values are already stated in the Z table, what's left to do to find the area under the normal curve is to analyze the z-score and table. Here are a few tips to keep in mind to make it easier for you to solve for the area under the normal curve. If the given z-score says above, you have to find the equivalent value of the z-score in the table and subtract it from 1. If the given says below, you simply get its equivalent value using the Z table. And lastly, if the given looks for the area between two z-scores, you simply take their equivalent values in the Z table and subtract both values from 1. That's all. Thank you. We will be discussing about the application of normal distribution. The problem on normal distribution is presented on the screen. Let us read the problem. Entry to a certain university is determined by a national test. The scores on this test are normally distributed with a mean of 500 and a standard deviation of 100. Tom wants to be admitted to this university, and he knows that he must score better than at least 70% of the students who took the test. Tom takes the test and scores 585. Will he be admitted to this university? Now let's solve for the answer. First, let x be the random variable that represents the scores. X is normally distributed with a mean of 500 and a standard deviation of 100. The total area under the normal curve represents the total number of students who took the test. If we multiply the values of the areas under the curve by 100, we obtain percentages. For the given, x is equals to 585, while z is equals to 585 minus 500 divided by 100 equals to 0.85. The proportion P of students who scored below 585 is given by P is equals to area to the left of Z is equals to 0.85, and that will give us this result of 0.8023 or 80.23%. Therefore, Tom scored better than 80.23 of the students who took the test, and of course he will be admitted to this university. That's all. Thank you.